80,000 miles of wire. 2 towers 746 feet tall. A single span of 4,200 feet across open ocean. This is how engineers stitched 2 headlands together. The Golden Gate is a tidal strait where the Pacific meets San Francisco Bay. Currents run past 7.5 knots. Fog hides the cliffs for half the year. Before any steel arrived, the work began with sound and string. Survey crews triangulated the headlands from both shores. A small steamship lowered weighted lines into the channel, measuring depth foot by foot. The southern anchorage would sit on solid serpentine rock. The northern pier would have to stand inside the open sea. Every later decision depended on these first measurements. On the San Francisco side, crews carved into the headland above Fort Point. The southern anchorage block would weigh over 60,000 tons, designed to resist the constant pull of the main cables. Excavation reached down to fresh serpentine bedrock. Every fracture in the stone was mapped and grouted. Steam shovels stripped overburden by the truckload, and narrow-gauge rails carried the spoil out to the shore. The pit grew wider than a city block. While the south side was straightforward earthwork, the north side posed a harder problem. The Marin Pier could rest on shore. The South Pier could not. The South Pier had to be built 1,100 feet from shore in open ocean. Engineers drove a timber access trestle out from the headland, then constructed an elliptical concrete ring 65 feet high to enclose the work zone. Inside this cofferdam, water could be pumped out and crews could pour the foundation against bedrock. But Pacific swells broke directly against the structure. A freighter struck the trestle in heavy fog and tore out 100 feet of it. The ring held. Once the seal was complete and the water emptied, divers descended to clear the seabed before any concrete went in. Concrete went in continuously, day and night, to avoid cold joints that could weaken the pier. Over 130,000 cubic yards filled the south foundation alone. The pour sequence was timed against the tides. On the Marin side, the north pier was simpler, built into the shoreline rather than offshore, but still required deep cutting into the cliff face. Meanwhile, the south anchorage block was finished, and the north anchorage carved straight into the rock of the marine headland. 4 points of contact with the earth, sized to hold the entire bridge in tension. The towers came next. Each tower is a structure of riveted steel cells, not a solid mass. Hollow boxes joined together at the corners, like a steel honeycomb. This design saved weight while resisting wind. Pieces were fabricated in Pennsylvania, shipped through the Panama Canal, and barged into place. A traveling derrick rode on top of each tower, lifting the next section into position. Below it, riveting gangs drove home over 600,000 rivets per tower. The work was done without safety nets at first. 11 men died before a net was finally strung beneath the deck level. With the towers topped out, the crossing began. Crews strung a footbridge, a catwalk, between the tower tops, 6 lanes wide and 1,800 feet across. From it, cable spinning began. Each main cable is not one cable, but a bundle of 27,572 parallel wires, each about the thickness of a pencil. A spinning wheel ran back and forth between the anchorages, laying 1 loop of wire per pass. Loop by loop, the cables grew. The total length of wire used would wrap the equator 3 times. Once the spinning was complete, hydraulic presses compressed each bundle into a tight cylinder 36 inches in diameter, then wrapped it in soft wire and a protective coating. Cable bands were clamped on at 50-foot intervals. From each band, vertical suspender ropes were lowered. These would carry the road deck. With the cables curving across the strait and the suspenders hanging in line, the bridge had its skeleton, but no surface. The next step was to hang the deck itself, 6,450 feet from anchorage to anchorage, suspended entirely from wire. Deck construction worked outward from each tower in both directions, balanced so the towers would not be pulled out of plumb. Sections of steel stiffening truss were hoisted from barges below, then bolted to the suspenders. The deck is itself a structural element, 25 feet deep, designed to spread wind and traffic loads along the cables. A safety net was finally installed beneath the work, catching 19 men during construction. They later formed the unofficial Halfway to Hell Club, With the deck closing toward the center, the bridge finally read as a single continuous form. With the structure closed, finish work began. Reinforced concrete was poured to form the roadway. Sidewalks were cast on both sides. Light standards rose at regular intervals, and the paint went on. The color, international orange, was not original to the design. The Navy wanted black and yellow stripes for visibility. The architect Irving Morrow argued the orange would complement the headlands and stand out in the fog. He won. Painters worked from suspended platforms, coating every exposed steel surface. The bridge would need repainting continuously for the rest of its life. On May 27, 1937, the bridge opened to people on foot. 200,000 walked across it that day before any car was allowed on the deck. 4 years of work, $35 million, 11 lives lost. The longest suspension span in the world at the time. The Golden Gate stands today not because the design was the safest available, but because it accepted the hardest site, a deep, open, fog-bound strait with currents that no one had ever built across. 80,000 miles of wire holding up a single road. Numbers, in the end, the bridge keeps.